We're here today to talk about power. The question that we come to is, why are watts important? Why do we focus on watts so much? It seems to me that watts are such a big deal because before there were powered loudspeakers, there were amplifiers and speakers that were built separately. And you needed to know how many watts a given amplifier could produce in order to match it to the loudspeakers you needed to play. That said, though, what do you actually want? When you want a loudspeaker, when you want a sound system, you don't really want a loudspeaker or a sound system. What you want is the end result of that. What you want is a room full of music. You want music that the audience can hear and enjoy. So the question is, how much power do you need to be able to do that? Is more watts better? These things are context dependent because the more efficient a loudspeaker system is, the less watts it needs. When you go shopping, the number of watts that something lists as one of the parameters is very largely independent of what you're using in order to achieve the goal that you want, which is music in the room. How does a loudspeaker utilize power? Loudspeakers, unless they're ribbon types, they have what's known as an impedance curve, which is to say that they don't produce the same resistance to electrical flow over the entire spectrum of their operation. Their resistance to electrical flow varies with frequency. What you want them to do is to reproduce the same sound pressure level with the same signal input level, so that when you ask it to do X, you get X. So when you ask it to do Y, you get Y. But you don't really know at any given point from the end user's perspective how much power it actually takes to get there. The peak points of the impedance curve of a loudspeaker will demand very little watts. The lowest impedance of the loudspeaker will allow the most current to flow and therefore will have the highest demand for watts. The question that we're asking about watts is like asking, how long is this rubber band? Well, it depends on how hard you stretch it. There will be a point at which it breaks, at which point that's the absolute maximum, but it's not necessarily where you want to use it all the time. You would want to not have it at its absolute limit all the time. So it's more important that you're not using all the watts in a given amplifier or specification than that you are using all the watts. When you're shopping for amplifiers and you're comparing amplifiers to amplifiers, you can look at how many watts, but you need to also look at how many volts and what the impedance is. And there's numbers that you'll see sometimes. It'll do more watts into 8 ohms than it will 4, or some will do more watts into 4 ohms than they will into 2. Even though a lower impedance with the same voltage will result in more watts mathematically, it's obvious that the power supply in that device can't sustain that output for very long. You're, again, at the point of choosing an amplifier, you're choosing an amplifier to match with a loudspeaker. When you're buying a self-powered loudspeaker, that matching job's already been done. So how many watts do you need? You need as many watts as it takes to get the sound pressure level for the music in the room. And the number of watts is just a number. It's basically one that you can never really know moment to moment. What you want is the result. You have to have power. You got to plug it in the wall. It's got to make something happen. How many watts does it take? You put the same amplifier, same number of watts on a different speaker, the effect isn't the same. You put a different kind of amplifier, different technology of amplifier with the same rated number of watts onto the same loudspeaker, the result isn't going to be the same. So pick your range, pick your target sound pressure level, and look at those numbers. The less watts an amplified loudspeaker provides in order to achieve those target numbers, assuming they actually reach them, the better. Because that means it's more efficient. That means that it's wasting less power, which means that it's probably not going to overheat, which means it's not going to get thermal compression, which is to say loss of sensitivity due to heat, which means that you'll be able to, in a lot of cases, run more sound pressure level on less outlets, less generator, less current draw, essentially. So the point is that we're building systems, and the systems are inclusive of amplification. They're inclusive of processing. They're inclusive of transducers. They're inclusive of power supplies and heat sinks, et cetera, et cetera. And if they do what you want them to do, then the people who are trying to convince you that the watts are the most important thing might be trying to convince you that the emperor is wearing clothes.